Hi everyone, welcome to online lecture 21. Today we will be discussing the results section and specifically how to write up the results section. So we already did our statistical review last time. We talked about how you would actually conduct the statistics, and now we'll get into how you would actually write up the section that deals with that. So what goes into the results section? Well, the goal is to report the results of the data analyses used to test a hypothesis. So you really want to think about just the facts here. You don't really want to discuss why or how the experiment was performed, or even allude to whether your results are good or bad, expected or unexpected, interesting or uninteresting. It's just the facts of what you got, okay? So let's start by setting the stage. How do we set the stage? Okay, so for part one, we're going to use some basic descriptive information. You're going to report the descriptive information for the independent variable and the dependent variable first, followed by the demographic variables that you included. So you're going to use mean and standard deviation for quantitative variables. This will be your dependent variable, along with any demographic variables that are continuous, like age. You're going to use percentages for qualitative variables. This includes your independent variable and any demographic variables that include categories like gender, race, year in school, etc. So let me give you an example of how this might look. Now, this is going to be my example that I'm going to work through with you today is based on some completely fake data set that I've come up with that talks about what are the differences in intelligence scores amongst Vulcans, Martians, and humans. So I wanted to stay away from anything that might be even close to one of yours. So I went with something really outlandish, okay? All right. So amongst the participants, 32% were Vulcan, n equals 16, 28% were Martian, n equals 14, and 40% were human, n equals 20. That's the description of the independent variable. Now, your independent variable may only have two groups. That's perfectly fine. This one happened to have three. That was the independent variable. Now we're going to discuss the dependent variable. The participants' CroSPIT scores, and that's cross-species intelligence test, range from 550 to 780. M equals 680, SD equals 63.73. So here we're just telling you the range of the dependent variable scores along with the mean and standard deviation. Okay, now we'll get into the demographics. In addition, amongst the participants, 64% were female, n equals 32, 36% were male, n equals 18. We only happen to have two categories for gender in this particular example, so that's the end of that sentence. And you can see it's a categorical variable, so once again, we use the percentages and the ends. Now we're going to do a continuous demographic variable like age. The age of the participants ranged from 22 to 45, mean equals 27.54, standard deviation equals 5.07. So basically, you can use this exact sort of wording for your own write-up of setting the stage. Okay, you just have to substitute in your own variables. Okay, and your own numbers, of course. Now, I do have a little bit of a bonus for you in setting the stage. And if you care to complete it, you will get some bonus points on the final project. Setting the stage, part 2. Are your groups equivalent? Compare your groups as defined by your IV on the demographic variables you created. So in other words, this isn't a formal comparison. That's why the comparison quotes. It's not going to involve any inferential statistics. It's just descriptives. So in other words, if I have a, if my IV again is species, I would look at the age maybe of the people in the the human group on average, in the Martian group on average, and in the Vulcan group on average. And I'll show you an example in just a second. Once again, you'll use mean and standard deviation for quantitative variables, continuous variables, and percentages for qualitative variables, your categorical variables. Okay, so let's take a look at this bonus. The age of Vulcans ranged from 22 to 45. Mean equals 29.13, standard deviation equals 5.50. As compared to the age of Martians, which ranged from 22 to 41. Mean equals 29.43, standard deviation equals 6.05. And humans, which range from 22 to 33. Mean equals 24.95, standard deviation equals 2.37. So you can see what I did is I now gave the ages for each level of my IV, for each category within my IV. And I'm going to do the same now for gender. Of the Vulcans, 75% were female as compared to 71.43% of the Martians and 50% of the humans. So why don't I mention male here? Why don't I mention the other category? Because we can kind of figure that out. If 75% of the Vulcans were female, and we only have two categories in this case, then 25% must have been male. And if 50% of the humans were female, then again, because there's only two categories, 50% must be male. Okay. And that is worth 5 points on the final project, if you care to do that. Okay, so it's a quick way to get 5 additional points. And that's out of 100 points for the final project. Okay. So now the opening act. What statistical analysis are you using? Okay, so I want you to observe that there are 2 sentences in a row that start with all data, right? One beneath the other. You're only going to use one of those sentences. If you have 2 groups for your independent variable, you use the top sentence starting with all data. If you have 3 groups for your independent variable, you'll use the bottom sentence starting with all data. So let me read through both of them. All data were analyzed using an independent samples t-test with species, Vulcan, human as the independent variable, and duration in seconds of hula hooping as the dependent variable. Or if you have 3 groups for your independent variable, all data were analyzed using a one-way ANOVA with species, Vulcan, Martian, human as the independent variable, and duration in seconds of hula hooping as the dependent variable. Post hoc analyses were completed using Tukey's HSD. Now, regardless of whether you chose the first all data or the second all data, here's what you should write next. An alpha level of 0.05 was used for all statistical tests. Okay, so we're just going to keep our alpha, all of us, to 0.05 just to make life easy. If you really felt like you wanted to get fancy and do something different like 0.01, just come talk to me. But we're planning as a group to keep it pretty much at 0.05. Okay, so that describes what you're doing. And again, you can use this exact wording. It's perfectly fine for your write-up. You just have to substitute in your independent variable and your dependent variable. And again, species in this case is the independent variable, and hula hooping was the dependent variable. Okay. Now we get to the show. What do we do here? We're going to restate the hypothesis and then give the result. So let's do each of those things. Okay. Now I'm switching examples on you, but don't let that fool you. It's still basically giving you what you want for a result. It will be recalled that the men are expected to be more emotionally expressive, producing more tears than the women when watching the film. Okay, that was their hypothesis. And you can see that men versus women in this case is the IV, independent variable, and being more emotionally expressive is the dependent variable. Now we're going to give the result. As shown in figure or table 1, whichever one you want to do here, the men produce more tears, M equals 6.22, standard deviation equals 0.88, than the women, mean equals 2.18, standard deviation equals 0.64. Now here is the potentially tricky part. We got to report our t-score. So how do we do that? Okay, so the actual t-score from the output was 5.79. So if you look and see the actual t value in your output, you would see 5.79. The degrees of freedom is 38. And the p-value in this case was 0.008. All right, so you always write t, kind of an italicized t, in parentheses, the df, equals the actual t value, comma, p is your actual sig value. Now, there is something I want to remind you about the sig value, and I know I talked about it in the statistics section, but I'm going to mention it again because it's that important. If you have a two-tailed test, you didn't specify which group was going to be higher, better, greater, smaller, lesser. If you have a two-tailed test where you just said the groups were going to be different, leave the sig value alone. If you have a one-tailed test where you did specify greater, smaller, lesser, lower, any direction, divide that sig value by 2. I know that's a little counterintuitive, but divide that sig value by 2. That's your actual p-value here. Okay, all right. Then we continue on and answer the question, was the hypothesis supported? If your p-value is less than your alpha, less than 0.05, then it would look something like this. The hypothesis that men cry more than women in response to visually depicted grief appears to receive strong support. Let's say the p-value over here was not 0.008. Let's say it was 0.06. Well, 0.06 is higher than 0.05, not lower. So then we would have said the hypothesis that men cry more than women in response to visually depicted grief does not appear to receive support, or does not appear to be supported. Something right along those lines. Okay, that's the show. So let's look at a couple other examples just to make sure that the t-test part makes sense. UW students taking statistics courses in psychology had higher IQ scores. Mean equals 121.37, standard deviation equals 14.26, than did those taking statistics courses in statistics. Mean equals 117.85, standard deviation equals 10.36. T of 44 equals 1.23, P equals 0.009. And here's one more for you. Over a 2-day period, participants drank significantly fewer drinks in the experimental group, mean equals 0.67, standard deviation equals 1.15, than did those in the waitlist control group, mean equals 8.00, standard deviation equals 2.00, T of 4 equals negative 5.51, P equals 0.005. Remember, t-scores can be positive or negative. ANOVAs can only have a positive score, and we'll get to those in just a second. Here's your ANOVA example. An analysis of variance showed that the effect of noise was significant. Now let's talk this one through. Okay. Just like your t-score was after the equal sign, your f-score is after the equal sign. Here it is, 5.94. So why do we have two numbers where we had one before in the DF area? Well, one is your between subjects DF, that's your 3. The other is your within subjects DF, that's the 27. And then once again, we report our p-value. Okay. When we're doing an ANOVA, we typically do not talk about specific one-tailed hypotheses. So if you have an ANOVA, most likely you are going to be working with just the two-tailed P and leave that alone. If you feel you have a different situation, please come talk to me. Now, post hoc analyses using Tukey's HSD indicated that the average number of errors was significantly lower in the white noise condition, mean equals 12.40, standard deviation equals 2.26, than in the other two noise conditions, traffic, mean equals 13.62, standard deviation equals 5.56, and industrial, mean equals 14.87, standard deviation equals 4.82. Okay, so that's how that would look. Okay. Now, I want you to use either a table and a figure, such as a bar graph, or two figures to show off your data. So either way, you're going to do two things. It's either a table, one figure, or two figures. Okay. So here's an example of what a table looks like. Mean activity score as a function of injection type. Here is the injection mean activity score for the groups of saline and 40 milligrams per kilogram of cocaine. And the mean is 22 and 50. The standard deviations are in the parentheses next to it, 5.4 and 7.2. And it even says below standard deviations are presented in parentheses. Okay. The tables are okay. To be honest, I think figures are a little bit nicer, and I typically recommend people go with two figures. Here's an example of a figure. We have mean attention score over here. That's our DV. Along the bottom, we have birth order. That's our IV, our independent variable. We have our firstborn, our middleborn, and our lastborn. And what I really like about bar graphs is you can see right away that lastborn and firstborn don't seem so different, but firstborn looks different from middleborn, and lastborn certainly looks different from middleborn. Now, we don't know. We'd have to look at the actual numbers to see if that was true, but that's what we can immediately get a look at. Okay. So typically, if you're going to do two figures, what I recommend is that your first figure be about the IV and the DV, kind of like this one right here. And then you do one more related to one of your demographic variables and the DV. Okay. Now there are other choices there as well, but that's typically what I recommend. So maybe after this one, I would do another one about year in school and mean attention score, and then I would have freshman, sophomore, junior, senior, or what have you. Okay, by the mean attention score or whatever is your DV. Okay. So just a couple other details for you that you may or may not have been noticing as I was reporting things out. You want to use two decimals for statistics for your means, for your standard deviations, for your t values, for your f values. And you're going to use 3 decimals for p values, which is nice because that's how SPSS reports it. So you can report it very much the same way. And all statistical symbols that are not Greek letters should be italicized, like mean, standard deviation, n, which is, remember, n is sample size, t, which is t-score, f, which is f-score, p-value, etc. Okay, all right. That's all I have for you today. Hopefully that cleared up a lot of how to write up the results section. Stay tuned for something else that I'll give you that also may help you write up the results section, a little bit of a template for that. So stay tuned for that. And if you have any other questions, please feel free to ask in class. All right. Take care. Stay well. I'll see you next time.